Good afternoon, everyone. So here we are, let's see, it is March 2nd, and we are going to begin our discussion about objects and classes. So let's go ahead and begin. So of course, our quote of the day, I may have used this one before with you guys, I'm not sure about last semester, but a very wise Jedi Master once said, "You must unlearn what you have learned." And so, in a sense, we are going to build off of what you've already done, but there are going to be some major changes because you're going to be learning a specific type of programming. Now we're going to focus on object-oriented programming. So when I was your age, actually Java was a very, very new language and wasn't even taught in the schools that I was a student at, and so so all I knew as far as programming was concerned when I graduated from my university was just what you've already learned pretty much in the first semester, and so things have gone well beyond what they were some number of years ago. All right, so why do we need to move on into object-oriented programming? Right, you've been able to solve a lot of problems already using simple things like if statements, loops, methods, functions if you're in other languages, arrays, but suppose we might want to develop a user interface, or we might want to create a type of object where the same tool can have multiple, let's see, things that go with it. Let me give you an example from the assignments. We created a store program last semester, right, where you can do different ways of being able to get information into the program using user input or text files. We also showed you many ways about how to get information out of the program using the same text files or displaying to the screen. But one of the things was, you know, if you wanted to have that text file represent a list of products, and each of those products has a name, a quantity, a price, a product ID, like a barcode kind of thing. Like, so you had to create a new array, right, for each thing that we were storing. So you had to create an array for all of the barcodes, and an array for all of the names, and an array for all of the prices, and an array for all the quantities. All right. What if we wanted to add a new piece of information? What if each product needed to have a calorie count for food items, or each product needed to have a weight? How many grams is it, you know, or a size, like how big is the box, something like that. And we need to add that for each product. We're now going to create an entirely new array, right, for each of those things that we want to add. But if we could have, oh, that's a kind of just noticed the message there. So if we wanted to add that, if what we wanted to have was have a product object, and within that product object was each of those things, a barcode, a name, price, quantity, then we could create an array of the product object. And then in order to add a new piece of information that we are storing in there, like a weight or a calorie count or whatever, then we don't have to create a new array. We just have to change the definition of what a product is. Okay? And that's what we're going to start learning about this semester. All right, so without further ado, that's a lot of reading. We'll skip over that. That's also kind of a lot of reading, but basically it's kind of what we talked about just now, that an object can represent something in the real world identified, and then we can give that object a set of data fields or properties or attributes, and then we can also have each object would also have a behavior defined by methods. Okay, so the object is the real thing, and the thing that we use to define what an object is we use a class. So what you will learn is that so far class has been kind of this reserved word for, public class, the name of the Java file. It's actually been something else all along. You just didn't know it yet. And so the class will operate like the blueprint, like if we were an architect. The class will operate like the blueprint for how we will define an object. The object that we create, the objects that we create, will be like the thing itself, like the building or anything that we can create. Okay. So if we look here at an example here, we might create a class called circle. Now, a circle can have a data field like a radius. And then we can also have a method called getArea. But then each instance of that circle that we create is an object. So the blueprint is the class circle. The actual thing itself is an object. Okay. So question, why do you think getArea is a method? Why didn't we just have a data field like radius, another data field, diameter, another data field area, another data field circumference? Why not just store all those different things as data fields instead of having a method called getArea? What do you think? Well, it definitely takes up less memory space, but what is the area of a circle? What's its definition? So that's similar, data redundancy, and that's another way to say it takes up less memory space too. Yeah, that's kind of the same. How do we determine what the area of a circle is? Right, so yes, pi times the radius squared, right? So if we know the radius, we can calculate the area. We don't need to store the area as a separate data field because the area, we could call that derived. There's another word called derived, right? So if we know the radius, we can calculate the area. In the same way, if we know the radius, we can calculate the diameter. It's 2 times the radius. Also, we can calculate the circumference, right? We don't need to store all those other things as extra data when those are things that are actually calculated based upon one piece of information. To kind of explain why that is, in terms of the circle is actually defined as all set of points within a plane, all set of points that are a specific distance away from some central point. So the center of the circle, if we know where that is, and the radius, the distance that we're calculating, then we can know it's the set of all points that are that distance around that point. Okay, so really the radius is the only real piece of information that we need to store to be able to calculate anything related to a circle. Okay, as I said before, classes are the things that define the objects that we will create. So a class, again, is like a blueprint. The object is like the thing itself. So here we can create a class called circle. We can create a data field called radius. All right. Now we'll talk about what constructors are. Constructors are a special method that a class will use to create a new object of that type. Then we can also create our own methods that calculate and return a value, or calculate and don't return a value. Maybe they do something else. we can also use them to change. We can also use our methods to change the value of data fields as well. Okay, so we talked a little bit. No, we talked a little bit last semester about flowcharts. UML has what's called activity diagrams that we use for flowchart representation of methods, right? But then we also have UML class diagrams, and these are going to be very, very important this semester as we start talking about object-oriented programming. But notice that the class will be represented like a box here, like a rectangle. And in the top thing, we have the class name of whatever it is. Now, I want you to notice that, what's the word? The proper way, the normal way there's a special name for the format of how to do things. I can't remember what it is. My English is going the more Turkish that I learn, I think. So, but for classes, we have a capital letter to start with, and then all the others are lowercase. Of course, obviously we can do camel case or underscores to separate words within a class name if the class name is made up of multiple words. But remember, this is different from the variable names as we talked about. Remember, variable names we're supposed to start with a lowercase letter. Class names will start with an uppercase letter. Again, there's nothing, the compiler won't get upset with you if you make a class name with a lowercase letter to start. It's not about that this is a compiler error. There's no error in that. There's no runtime error. There's no compiler error. There's no logical error. It is just considered standard practice for us reading our code to have class names start with uppercase letters. Okay. The constructors will need to have the same name as the class name, right? And then methods again will have lowercase letters to start, and then in this example, what they've done is done the camel case that we talked about. Okay, so you have class name at the top, any data fields or attributes in that second section, and then any methods, including a return type and any parameters passed and those types inside of the parentheses like this as part of the method section. Now these are the how the UML notes for objects. So this is the class, the blueprint. This is the object, the thing itself. We have a name, like a variable name for the object, the type, okay, what class type did we use to create this? And then data fields. Now notice we don't include the methods in the objects because all these methods are included in here. The only thing that we're including here for the object itself is the data field to give it what value did we give it? What value does that particular object have? Okay. We'll look at an example. Okay. Here in a moment. Okay. Constructors, again, are special methods that we use to create, to construct. There's another word called instantiate. It's a fancy word, but it means to create an instance of an object. Constructors, just like any method, any other method, we can overload them, just like we talked about last semester, where notice we have a version of it that takes no parameter. We have a version of it that takes a parameter. Okay. If a constructor doesn't take any parameters, we call it a no-arg constructor, meaning it takes no arguments. Okay. It's not on this slide. Okay, it doesn't say it on this slide, but one of the things that I'll tell you is that if you don't explicitly create a constructor method, the compiler will do it for you. It will create a no-arg constructor that has no arguments. Okay, that has nothing inside of it. Okay. So every time that you guys created a public class for each of your assignments or in lab or whatever, you didn't type a constructor in there, but the compiler created one for you. Okay. So not that you used it, of course, but it was still created there in the background. You just didn't see it. Okay. Some key points to be made: the constructor must have the same name as the class itself, and a constructor does not have a return type. We don't say public static void constructor name. We don't do anything. We just here, I'll show you this example back again. There, notice there's no return type. There's no we can put a visibility modifier, but there's no return type, and it can take a parameter, but it doesn't have to. Was there anything? Yeah. So we use the new operator when creating a using the constructor to create an object. So here, for an example, new, give it a class name to create an object of whatever that type is. So here, new circle creates a new circle object with no arguments. This creates a new circle object with an argument. Okay. And this is what I said before, that a class with no constructors is a default constructor with no arguments that is going to be automatically created. The compiler has to do this because any class must have a constructor in order to make an object of that class. So how do we use our new objects? We can create using a reference variable. This will look very similar to how we've done this with variables of what we called primitive types or strings. You guys remember that we can create strings using this notation, right? And so here it's just like with anything that we've worked with before in terms of arrays, strings, lots of other things that we've done, right? Where you say, okay, I'm going to have a variable of type circle called myCircle, and I'm going to create an object. It's a circle with no arguments, and I'm going to have that variable point to it. Okay. Let's see. Let's see if I can pull this off. Okay, so I'm going to draw something like I would normally draw on the board. All right. When this line gets executed, okay, so let's look on these two sides together. Okay, so let's look at this first. Hey, draw for me. There we go. Okay. All right. So first, what happens here is out in memory, right? We'll create this variable. Okay, this is difficult, but we'll see if this works out. Okay, we create a variable called myCircle that it's going to point to something that must be of type circle. Okay. Then it's going to create this circle object. So then out here in some place in memory, it's going to create this circle object. Okay. Just like it did, just like we talked about this, where the variable created was an array variable and the thing out in memory was an array. The thing, we created a variable for a string. We created a string out in memory, right? Same kind of concept here. So then this equal sign says take this thing I created and point this variable to it. Whatever its address is, take it and put it there. Okay, so now from this point forward, when I reference myCircle, the variable, I'm going to get this object in memory. Okay. All right. Is that clear? Everyone understand that? Okay. Remember, ask me to slow down or ask me for clarification if you don't understand something. I want to make sure that you guys understand the things that we're talking about here, because it's very, very important. Okay. So once this thing is created, how do we access parts of it? Okay. Okay, so we can access a data item using the dot notation. So we can say myCircle whatever that object is, dot radius will give me the radius value. This will act just like a variable. Okay? I can use it to assign a new value to it. I can use it to get the value that's currently there. Okay?
Dr. Lede?
Sure.
To be honest, I kind of don't understand what the different objects make. And as you go on with the lesson, I continue not understanding because you gave
Okay.
an example trying to explain if we have a radius of a circle, we can find area of it and all that. Didn't we already do those on our not object-oriented programs as well? I didn't understand the base of it, I should say.
Right. So like if we were to only have access to what we talked about last semester, in order to say get the area of a circle, for example, we could create a method called get area of circle, right? And then pass it a value for the radius, and then that method would return the area of the circle, right? This is more like we are going to create, now the circle example is a very, very simple example. But like, for example, let's say that, going back to the store program that we're going to continue, let's say you have a product, and that product has different data values, has a product name, a price, a quantity that we have in our store, stuff like that. So let's say that I wanted to buy some of the product, which would mean I would want to, let's see, I would want to buy 3 Snickers bars or whatever, right? What I could do is I could create a method within the product class that is buy product and give it a value, give it a quantity of how many I'm buying. And then that would reduce the quantity for that product. Now, I don't have to then, in my main program, I don't have to say, I don't have to go searching through an array for a specific product ID. I don't have to change the value in that particular array. I can just change it for that product. So there's a lot of methods, a lot of data that kind of goes together as part of a single product in this example. The circle is a very simple example that we might not want to, if that was the only thing we were creating, maybe we wouldn't create a circle class in order to create circle objects. But as we will see as the semester goes on, circle is just one of many geometric objects that we may want to create and be able to have methods for. And then, of course, once we start getting into inheritance, that is where we have a parent class that has attributes and methods that we want all objects of that type to be able to have. So I don't know if that clarified your question there. But the idea is that we're not going to just create maybe one circle and just deal with that one circle. We want to be able to create many circles that all have some common traits. So all circles have a radius. All circles we want to be able to get the area for them. All circles we want to be able to get the perimeter, the circumference for them. And instead of having to write a new method for each of those, then we want to be able to say, okay, all circle objects, we can write one method called getArea, and then anytime I create a new circle, in order to get that circle's area, I just have to call that method. So like, for example, here, this example here. So in order to get the area for that circle, I just have to call the getArea method. And that will tell me the area for that circle. Okay. And in this way, the radius can act like a variable. I can set its value, I can get its value, and so forth.
I think I understand a little bit more. Thank you.
Yeah. I think once we start showing maybe some examples, it would help. Okay, so here, this basically works very similar to what I just showed in the little drawing on the red with the red pen, We declare my circle variable. It doesn't point to anything. We create a circle object with a radius of 5. And we make it point to it. So now this points to that reference value. Okay. Then we can create another circle. New variable, your circle. Doesn't point to anything. We create a new circle object, has a radius of 1. The reason why it has a radius of 1 is the default value we set was 1. And then this equal sign makes a point to it. All right. So now when we do this, this changes. Remember, this radius acts like a variable, right? And so now it sets that value to 100 instead of the 1 that it was before. Okay. A caution, I will say, is last semester we were able to use methods from like the math class or the random class or the string class. All of those were, well, not the string class. We'll come back to that one. We were able to say math.method name with an arguments, right? So math.pow, for example, raising 3 to the 2.5 power. Okay. So can we do that using just the simple circle.getArea or circle.getArea? And the answer is no. In the getArea can't be done that because it's not static. So remember last semester we had you type public, static, return type, method name. And I said, right now just type static. We'll tell you why later. Well, now's later. Okay, so static means that it is a method that can be used without having to create an object of that type. So we don't have to create a math object in order to use the POW method. The POW method, we can call it on its own. But getArea, if we don't create a circle, what is the area of a non-existent circle? What is the area of a circle that doesn't exist? That doesn't really make sense, does it? So by making getArea not a static method, a non-static method, then we are saying this method only makes sense for an object that exists. All right. So in this case, we will use the particular reference variable, my circle, with the getArea method to say what is the area of this particular circle. Okay. So for now, just understand that that's the case, but here later in this section of slides, which we probably won't get to today, we'll talk a little bit more about that. Okay. So we'll do a couple more slides, and then maybe if we have time to show some examples, and then we'll talk a bit about that. Okay. This is an important part of this, is that when we put a class variable, like here in the case of student, we have name, age, is science major, gender. Okay, all of these things come with default values. All of these class variables come with default values if we don't set them when we create them out here, outside of any methods. Okay. Which means that if we try to access that variable without giving it a value, we will not get a compiler error. We will not get a compiler or a runtime error. This is different from something that we've experienced before, where inside of a method, like the main method, if we didn't give a variable a value, we could sometimes get a compiler error that said, hey, this variable might not have been initialized. Okay. So this is slightly different from before. So class variables work a little bit differently than what we call instance variables, or no, local variables. Okay. All right. So if a reference type does not reference a particular object, so like for example here, string is an object, the default value is null. So it doesn't give it a blank string. Remember a string with no characters, because a string with no characters is still a string that has a value. The value just happens to be no characters. Null is different. Null means it doesn't point to anything. So for example, here, let me show you. I could create a string variable, right, that doesn't point to anything, so it's just null. Okay, but if I created an integer variable, right, its default value will be 0. Okay, so it has a default value. This does not point to a string object. This points to nothing. Okay, that is a special value. Null becomes a very important concept in lots of different programming fields. Database, for example, like I taught earlier today, this right here. Okay, so a default value, if I were to run this, right, I will not give I will not get a compiler error for this. Okay, because these all were given default values. In order for the object to be created, in order for the student object to be created, all of these were given default values. However, in this example, right, this would give me a compiler error because I didn't give X and Y values. Okay, so it's a little bit different. If it's a variable that exists inside of the method, I will get a compiler error for not giving it a value. I'll give it for not initializing it. Here, in order to create a student object, this had to give default values to these. Okay, so let's actually go ahead and move away from the slides. Oh. Sure, I'll keep the ink. I'll keep the ink annotations. Okay, so you know what? There's not one in here, is there? Okay, let's create that. Let's create that student class. Okay, there we go. All right, so let's. Okay, and then let's also create the test class that they talked about there. All right, so if I were to compile this, I should get no error, right? Okay, so I compiled my student class. By the way, that's something else that you guys haven't seen yet, but it's important for you to know, is that when you compile this, notice that it also compiled the student class too. So I want to show you that again so that you can see that that happened, in case you missed it. Okay. So here, notice I'm not compiling the student class. I didn't compile this. I'm compiling just this one. Notice that it also compiled the student class because this one depends on the student class being compiled. Okay, so if there were a compiler error in the student class, this should not work. So let me go back and show you that. Good question. Let's take a look. Let's do this. Okay, so now I don't have a student class, right? I only have a student2 class, right? So I don't have a student class. So if I compile this, oh, I got a compiler error, right? Because this does not exist. This student class it's looking for doesn't exist. So let's, there is a way around that, and I'll show you right. Okay, so I'm going to save this. Okay, so I'm going to compile this. Okay. Let me see here. I'm going to have to do this through the folders, though, I think. I'm going to have to do it here. Okay, so now, because if I do it through here, it'll delete the class file, and I don't want it to do that. I want it to keep this. Okay, so this student.class file still exists. So if I compile this, it should still work. Yep, and the reason why it does is because in order to access this student object, right, it needs access to something called student.class. It actually doesn't need the student.java file. I could give you a lot of class files and you could run them by creating your own test type of thing. So if I were to give you this student.class file, which is the compiled version of this, right, you could create this test.java file in order to run it. And you actually don't need to have access to this .java file in order to run it. Okay. Just like I showed you guys last semester, where if I gave you the class file and you ran it from the command line, same thing. You don't have to have the original .java file in order to execute some code. You can have the class file only. All right. So let me go back over here because I want to not make this too confusing. There we go. Okay. So I'm going to compile this. I'm going to run it. Okay. And notice that the name is null, the age is 0, the science major is false. These are all gender was, what type of data was that? The character, okay. Which is basically what's called the null terminator character. Okay, we can change those values if we want afterwards, right? Oh, sorry. Let me do. So I don't make it because there's no favorites. No, we're not going to do that one. So now, if we, after we do that, now display it. Okay, so we're going to display it initially. Okay, all these initially. Now notice here in JGrass, what we can do is we can look at the different values that are the data items inside of that object. So now here, notice that changed, right? Name changed. Its science major changed. So now when we display it, we're going to get the new values for those things that we changed. Okay. All right. Let's go and show you the other one too while we're at it. Okay. So now, if I try to save this, right, and if I try to compile it, I should get a compiler error. Yep. All right, because now it's telling me that this variable is not initialized. So class variables like this get default values. Local variables like this do not get default values. Okay, big difference. Make sure you understand the difference there. Okay. All right, and one of the things we will show later, so here we're coming up on the end of our time here for today. All right, one of the things that we'll see later is that actually we don't really want to have our variables be able to be modified like this just through the dot notation, and we'll talk about the reasons for why. Okay, so for those of you who've been in this class before, you know that we're going to get into we're going to talk about security as far as that's concerned, and how to not make our variables directly modifiable. Okay. But we'll get into the whys and the hows of that. Okay. Let's see, a couple of things again. So make sure you respond to that poll, because as of right now, if we were to close that poll out today, though, on the main channel, on the general channel, then what we would do is we would have 2 hours of class on Wednesdays and 1 hour of class on Thursdays. Okay, because that seems to be the one that most of the students, most of you, are selecting. So if you have an opinion, if you have a job where you want it to be something else, make sure you let it be known. Okay, because at the end of business tomorrow, 5 p.m. tomorrow, whatever the winner is, that's the one we're going to end up going with. Okay. Also, if you want to reuse any scores, yeah, that's my plan. Yeah, I'm gonna try to upload the new recordings to. I may do it. Yeah. Definitely gonna do it to the stream. Does anyone use Microsoft Stream? Because this can be uploaded to Microsoft Stream also, but I get the impression that none of you used it. Anyway, yeah, I think no. So, but YouTube, I know you guys all use YouTube, right? So I will, I'll plan to put this up to my YouTube channel, and I'll put a link to that list, to that playlist here in the general channel. If you want to reuse quiz grades, attendance grades, lab grades from last year or from a previous year, make sure you let me know by the end of the 3rd week of class. That's 2 weeks from tomorrow. Okay, so. Question?
Can you hear me?
Yes, I can hear you.
Yeah. So if I'm facing a problem, like any kind of problem, do I need to think about OOB, or just for the, like, if the problem was so big, so we need to use it?
I would say it's kind of like what I talked about last semester with if my wife asked me to kill a spider and I can go in there with a flamethrower or a shotgun or a slipper or a newspaper or something. Object-oriented programming is very useful for a lot of problems. But no, there are some problems that are much smaller and don't necessarily require object-oriented programming. Again, kind of like we talked about before, there's lots of different languages out there. You have C, you have Java, you have Python, HTML, JavaScript, PHP. There's lots of programming languages. That's because there's not one correct solution to every problem. I mean, even something like this, right? The phone, right? There's lots of telephones out there, and that's because different people want to do it differently, right? So I would say part of being able to, I would say there's 2 parts of being a good engineer. One would be determining the best tool to solve the problem you are trying to solve. Other times, you may be put into a situation where the tool is decided for you and you've got to figure out how to solve that problem with that tool. I think some of you have previous experience programming in C, for example. C is not an object-oriented language, not C# or C++, but C, the original one. And it's not object-oriented, but you can use things like structs in there to kind of do some object-oriented type stuff with it. But yeah, that's a good question. So knowing what tool is necessary. Yeah. All right. Any other questions? That was a good question. All right, guys. So we'll close out there for today. We will pick up and continue and finish off the intro to object-oriented programming on Wednesday, and move on into how to think in terms of objects, and classes as we continue on. All right. Thank you, guys. Have a good weekend, and I will see you on Wednesday.
Thank you, Hoca.